Today what we're going to look at is we're going to look at taking our mole triangle and taking our dimensional analysis and doing some very basic, very simple conversions. Okay? So let's start with one that we already have, and let's start with, we're going to do some with water because we've already done that triangle in a previous video. Okay, if you don't remember, here it is. 1 mole of H2O is equal to 18.015 grams of H2O, which is this many molecules of H2O. Okay, so that's our triangle. So now, just because of space, you're actually going to I'm going to give you more space to work these problems, but you're going to have your triangle, 1 mole H2O, 18.015 grams H2O, and then Avogadro's number H2O. Okay? And that's in molecules. So here's our first problem. So we're going to take, and let's start with something realistic. So let's go with that we're going to be able to do. And let's say I give you 10 grams of H2O. We go in the lab, we're working in the lab, and I say, okay, you need to get 10 grams of H2O. So you pour it in the graduated cylinder, you do the measuring the empty cylinder, you write it down, you pour in the liquid until you get 10 grams, and then you're good to go. But our reactions, our chemical reactions that we're going to be working with are all written in moles. Okay? So I've got to convert this thing I just measured to a unit that I can work with, which is moles. And if I didn't say it in the other video, this is a good place to say it. Why do we like moles? Why are we even doing this? Why don't we just stick with grams? And that's because we have 6.022 times 10 to the 23rd. We have 18.015. We have 10. Look at this number. This number 1 is a much simpler number to work with. Okay, so it takes all these complex numbers and it simplifies them, yet retains the actual information that we might need for other applications. So let's follow our process that we learned before with feet and inches. So I'm going to convert grams of H2O to moles of H2O. So first step, what am I given? 10 grams H2O. What's my conversion factor going to be? Well, I look at my triangle and I'm going from grams, so I've got grams here, to moles. So that's my conversion factor. Okay? So hopefully by now you remember how to do this. So we're just going to kind of skip a couple steps. So I've got what I've given on the line. What has to go on the bottom? Grams H2O, which is here, right? What number is with that? 18, right? So 18.015 grams H2O. How many moles is it? 1 mole H2O. Grams H2O cancel, grams H2O cancel, and now I'm ready to do the math. Multiply across the top, 10. Multiply across the bottom, 18.015. And now I divide those, and I should get, let's find out. My computer will cooperate. Okay, so okay, 10 divided by 18 18.015 equals. Is that about right? 10 is about half, so yes, that's right. I'm making sure my calculator's messing up. 0.55 0.55. What's the units? Grams have canceled and now it's 0.55 moles of H2O. And that would be your final answer. Okay? Pretty simple, okay? What is the most important part of this that you have to get right? There's two places. The first one is you have to calculate the molar mass correctly. And the second one is setting up the line correctly, setting up your dimensional analysis line. Okay, so let's practice another one. Let's use the NaCl triangle. Okay, 1 mole NaCl, and actually, let's do this, 22.999 plus 35.454, 58.453. 58.453 grams NaCl, Avogadro's number, formula units, form units. Okay, so here's our problem. Let's say you go out and you measure 100 grams of salt. 100 grams NaCl. How many moles is that? Okay. So we draw our line. This is our given. This is what we start with. What has to go down here? Well, what did I start with? Grams NaCl. Okay, and that number is 58.453. And what goes on top? 1 mole. You really have to write the NaCl, because we're doing that for a reason, because we're going to be doing this with multiple chemicals later on down the road. Okay? Sorry, my pen is acting weird. Okay? So now grams cancel with grams. So now 100 times 1 is 100. I have to write slower, I guess. 100 divided by 58.453. Okay, so let's plug it in our calculator. 100 divide 58.453 equals 1.71. So that equals, gotta fix my pen here. That equals, what did I say? That equals 1.71 moles NaCl. Okay? All right. So let's do 2 more examples where we're going to go the other way. So using our water triangle, we have 1 mole H2O, 18.015 grams H2O, and this is going to be molecules, Avogadro's number. Okay? So, but now here's the question. Now I have 5 moles of H2O. How many grams do I have of H2O? So, what do? We start with what we're given, which is 5 moles. What goes on the bottom? Moles, because that's what I started with. Where is moles on my triangle? It's up here. One of them. What am I going to? Grams. Where is that? It's over here. So I'm going to write 18.015 grams H2O. How does this work? Because these two values are equal, which means they're really equal to 1. So 1 times 5, is that going to change the value of what I've actually measured? If I handed you a cup and said, here is 5 moles, and then we were to convert this, because now we're just going to multiply across the top, multiply across the bottom and divide, would that change the value of what I actually hand you? No, it would still be the same amount. We would just use different language to talk about it. So let's do that. 5 times 15 is 75, 0, 40. So 90.75 divided by 1, which is going to be equal to 90.075 grams of H2O. Okay? Here, I'm going to write it bigger. 90.075 grams of H2O. Okay? Pretty straightforward. That part's pretty simple. So now we're going to go and we're going to involve Avogadro's number. And this is where it's really not that much harder. You're just having to deal with exponents like we did with our Bohr model. Okay? But we're going to be asked some of those questions. Okay, so let's stay with the same triangle. 1 mole, 18.015 grams H2O, and Avogadro's number of molecules. So let's go back and let's say I gave you, let's do 0.55. Yeah, here, let me erase. So let's go back. Let's do what, we converted grams to moles earlier, and we found this was 0.55 moles of H2O. How many molecules of H2O is that? Okay, so we do the same thing. 0.55 moles H2O is what we're given. So we put it on the line. What are we converting to? Or actually, what's on the line? So that goes down here. What's the number on the triangle? 1. We're going to be looking for molecules. So where's molecules? It's over here. So now we got to write the number. 6.022 times 10 to the 23rd molecules. Okay, H2O. Moles cancel. Now I just got to multiply across the top and then divide by the bottom. So remember from what we did earlier, there are 2 ways to do this. The easiest way that I find, honestly, myself, especially after doing the Bohr model, is to just go 0.55 times 6.022. Do the numbers. Do the numbers first. Equals 3.31 times 10 to the 23rd molecules of H2O. Okay? And now you have the correct answer. The other way to do it is to completely plug it in your calculator. Some calculators may give you some problems with this, so you may need to see me individually based on the calculator you're using on your phone. But here's how I would do it in the calculator. I would do 0.55 times 6.022. Let's see, where's the double E button on here? And yeah, E23 equals. Now, notice what it did though. It wrote the whole thing out. So now we have to count our decimal. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and 23. So it's still the same answer. 3.31 times 10 to the 23rd molecules of H2O. Another way you could do it, if you're using a graphing calculator, is you would write 0.55 times 6.022 times 10, and where is the exponent? Ten to the 23. And you get the same answer. You just got to be careful what your calculator produces as your final answer. Okay, so please see me with your individual calculator that you're going to be using, and I will help you figure out your calculator and how to do that. Honestly, to me, it's still the simplest is to multiply the numbers or divide the numbers, as we'll see in a minute, and then worry about the exponent. Okay, let's try another one. Let's do, just so you see it, let's do the same thing. Let's do 10 grams of H2O. Okay, let's say we were given 10 grams of H2O. Okay. And I'm asked to find how many molecules. So, what am I given? 10 grams. Notice this is a little different. So now I got grams of H2O. What number goes with grams? 18.015. What am I looking for? I'm looking for molecules. So what number goes here? 6.022 times 10 to the 23rd molecules. Okay? So now, this is where you have to multiply across the top, which will give you I usually do my scientific notation conversion at the end. 60.22 times 10 to the 23rd, 10 times 6.022, right? Divided by 18.015. So do 60.022, 60.22 divided by 18.015 equals 3.342. Which is a little different from what we had earlier just because we rounded the last time. 3.342, what's my final words? Molecules, is that right? What did I forget? I forgot that, didn't I? So you got to be careful. So that's times 10 to the 23rd molecules. Now, if they asked you how many atoms of hydrogen were in this sample, for every one molecule, how many atoms are there? So for every one molecule of H2O, how many atoms of hydrogen? There are 2 atoms of hydrogen. And now you could do that calculation. Okay, you won't see too many of those, but in college you probably will. All right, I've been talking long enough. Here are some sample problems. Go ahead and try them, and let's see what you get. If you need any help, please come see me.